Good morning everyone. Myself Chaitanya Sivasai. Today my topic is triple integrals. Moving on to the topic, introduction to triple integrals. Triple integrals are a way to extend the concept of double integrals to three dimensions. They are used to calculate the volume under a surface in three-dimensional space. The notation for a triple integral typically looks like triple integral f x comma y comma z into dv, where dv represents the volume element. Moving on to next slide, setting up triple integrals. To set up a triple integral, one must define the bounds of integration for each variable. The limits can be constants or functions of other variables, depend on the region of integration. Common coordinate systems used include Cartesian, cylindrical, and spherical coordinates. Moving on to next slide, evaluating triple integrals. Evaluating a triple integral involves performing the integration in a specific order, often dz, dy, dx, or its permutations. It is essentially to carefully manage the limits of integration for each variable to ensure accurate results. Techniques such as Kubin's theorem allow for evaluation of multiple integrals by integrating one variable at a time. Applications of triple integrals. Triple integrals are widely used in physics, engineering, and probability theory. They can be employed to find the mass of a solid with variable density or center of mass for three-dimensional objects. Additionally, triple integrals are used in calculating moments of inertia and electrical charge distributions in space. Moving on to assignment question. Determine triple integral x plus y plus z into dz dy dx, where R is the region bounded by the planes x equal to 0, x equal to 1, y equal to 0, y equal to 1, z equal to 0 and z equal to 1. Coming to solution, in triple integral x plus y plus z into dz dy dx, and substituting limits to the integrals x equal to 0 to 1, integral y equal to 0 to 1, integral z equal to 0 to 1, x plus y plus z into dz dy dx, and integrating with respect to z, then it becomes integral x equal to 0 to 1, integral y equal to 0 to 1 into xz plus yz plus z square by 2, limits 0 to 1 dy dx. Substituting the upper limit and lower limit, then it becomes integral 0 to 1 x equal to 0 to 1 and integral y equal to 0 to 1 x plus y plus 1 by 2 dy dx. Then integrating with respect to y, then it becomes integral 0 to 1 xy plus y square by 2 plus half y with limits 0 to 1 dx. Then it becomes integral 0 to 1 x plus 1 dx. Substituting upper limit and lower limit, then it becomes x square by 2 plus x with limits 0 to 1, then it becomes half plus 1. Finally, the solution is 3 by 2. Thank you for giving this opportunity.